Can zinc-based coatings be used for protection underwater? There has always been a debate in the industry about this issue. Today, let's discuss it. We know that when zinc reacts with water, hydrogen gas is produced. The release of hydrogen causes the coating to crack and deteriorate. If the water contains conductive ions, such as chloride ions in seawater, the consumption of zinc will accelerate, leading to the overall failure of the coating. If a zinc-based coating is combined with anti-corrosion paint, the amount of water vapor entering the zinc coating will be very small, and the corrosion process will be significantly delayed. The resulting zinc hydroxide forms a well-adhering and dense film, effectively preventing external corrosion. Therefore, the outer surface of ships is mostly protected by shielding isolation anti-corrosion paint, combined with sacrificial anodes for corrosion prevention. Of course, some people may ask why the water gates in hydropower stations use hot deep zinc spraying, followed by a sealing paint, intermediate paint, and top coat to provide anti-corrosion protection. This is different. The zinc coating on factory water conservancy facilities and coating equipment can be as thick as 120 microns, or even 160 microns or 200 microns. It is sealed with a 30 micron epoxy sealing paint, an 80 micron intermediate coating, and an 80 micron green rubber coating. The zinc coating is thick enough, and the intermediate sealing layer provides excellent shielding isolation, effectively delaying the occurrence of corrosion. This type of coating system is very expensive, and the quality control of anti-corrosion for hydropower station gates is also very strict. Even so, the anti-corrosion maintenance of hydropower station gates is still very frequent. Therefore, the most commonly used anti-corrosion system for underwater applications is the shielding isolation anti-corrosion coating, such as pure epoxy paint, epoxy glass and flake coatings, with a coating thickness of over 400 microns, combined with sacrificial anodes or impressed current cathodic protection. The anti-corrosion of this method lies in the thick shielding isolation coating, which blocks the invasion of external corrosive substances. Once corrosion occurs at a certain location, the emergency protection comes into play. It inhibits the spread of corrosion and protects the steel substrate. At this point, someone may ask, can we do without the paint protection and only use emergency protection? Theoretically, emergency protection can provide anti-corrosion protection, but without shielding protection, a large amount of sacrificial anodes will be consumed. Therefore, in terms of cost effectiveness, the combination of shielding protection paint and sacrificial anodes is the best anti-corrosion method.